Welcome to the final installment of our three-part series on serial communications, variables, and control structures and loops. This lesson focuses on control structures and loops. Control structures and loops permit execution of codes in nonlinear fashions. So typically when I have some code like this, these commands are going to be executed one after the other in sequence. So first the serial stream will be initialized to 9600 baud, pin 13 will be set as an output, and then pin 13 will be written to a low state using a digital write command. Now the loop function in an Arduino sketch is one of these control structures that permits me to execute a chunk of code over and over and over again. If you head over to the Arduino reference page and scroll down here to the control structures section, you'll see a number of control structures that have various uses for various applications for your Arduino. In this course, we're going to be focusing on the if-else, the for, and the while loops. These will be sort of the essentials that you'll need for this class. Let's start with if statements then. So if we go back to my code here, I'm going to set the pin mode of pin 2 as an input here. And you'll recall that pin 13 on your Arduino has an LED connected to it. So I'm going to use pin 2 as an input. I will digital read the state of pin 2. And if the pin is high, I'll turn on the LED on pin 13. And if the pin 2 is low, I'll turn off the LED on pin 13. So let's put some code in our loop function here to perform this task. So here's my code. I have an if statement, so if, and then in parentheses, I'm going to write digital read of 2. Okay, so I'm going to do a digital read of pin 2. If that state is high, if pin 2 is high or connected to 5 volts, then I'll execute the code in between my curly brackets here. So in the case where pin 2 is high, I'll digital write pin 13 high, which will turn on the LED. And we can go ahead and upload that to our Arduino Uno. I'll be using Tinkercad here such that I can show you the code as well as the hardware at the same time. So I've gone ahead and cut and pasted the code from the Arduino IDE into Tinkercad here. So I have the same thing running in Tinkercad as I do in the IDE. And if I go ahead and plug in my Arduino and run this program, you'll notice right now pin 2 is currently connected to a switch, and then the switch is connected to ground as well as 5 volts. So in the current configuration, even though the Arduino is running, pin 2 is connected to ground. So as a result, once I get into my loop function, I run into my if statement here, and this says if digital read of 2, if pin 2 is equal to high, then go ahead and digital write 13 high. Well, right now, pin 2 is low. So as a result, pin 13 is off, right? So pin 13 is low and the LED is off. If I switch to 5 volts now, however, now I'm sending 5 volts through my pin 2. And when I digital read pin 2, it's now high. So I now execute my if statement here. Digital write pin 13 high, and that turns on my LED. The problem here, however, is that the way this if statement is written and the way my loop function is running, if I go ahead and turn the switch to ground again, you'll notice pin 13 is still illuminated. Okay? Based on the way our if statement is written, there's no opportunity to actually digital write pin 13 low. So from here, we need to incorporate an if-else statement. Here now is my sketch with the if-else statement incorporated. Once I get to my loop function, I'll encounter the if statement. So if pin 2 is high, if it's connected to 5 volts, we'll write pin 13 high. We'll turn on the LED. Otherwise, or else, we'll write pin 13 low, turning off the LED. Let's see how that looks in Tinkercad. I'll go ahead and upload and run this new sketch. Pin 2 is currently connected to ground, so we'll go ahead and flip the switch here. So now pin 2 is connected to 5 volts. Pin 2 is high if I'm doing a digital read. I get into my if statement and I digital write pin 13 high, which illuminates my LED. Now, however, if I flip my switch back to ground, now pin 2 is connected to ground. It's in a low state. So now I run into the else component of my if-else statement. allowing me to digital write pin 13 low, turning off the LED. One thing that I'll mention at this point is it's often advantageous to incorporate a few select serial print lines for the purposes of debugging, to be quite honest. So in this section of code, I've now added a serial.print line saying that the LED is on in the case that pin 2 is high and I digital write 13 high, or saying that the LED is off in the case that pin 2 is low, this else component of the if-else statement, and as a result, pin 13 is written low. And when I run this code in Tinkercad, if I look at my serial monitor here, I'll see that the LED is off. That's correct. I'm in the correct part of the if-else statement. And when I switch pin 2 to 5 volts, sending it high, I'll see that my LED is illuminated and my serial stream is correctly identifying that the LED is on. Another important control structure, an important loop here, is the while loop. And the while loop says I'm going to execute some command or bit of code continuously while some expression is true. Okay? So if I look here in the code I've written inside of my loop function, I say while digital read of 2 equals low. So while pin 2 is in a low state or connected to ground, we'll serial.println waiting. So this will happen over and over and over again while pin 2 is low. Then once pin 2 is high, we'll start printing signal detected. Let's take a look at that in Tinkercad then. Here's the same code. We'll go ahead and upload and run, and let's take a look at our serial monitor here. Now I'm inside my loop function and I've encountered a while loop. So while digital read of pin 2 is low, so while pin 2 is connected to ground, we'll continue to print line the string waiting. And this will just go on continuously until pin 2 is high. So you can see in my circuit, pin 2 is in fact connected to ground, so it's low. Now let's go ahead and connect that to 5 volts. We'll send pin 2 high. We've now broken out of the while loop. This expression is no longer true. So now we're printing a serial.println and the text signal detected. And because the loop function is exactly that, looping, we're continuing to print signal detected. The last control structure we want to look at for this lesson then will be the for loop. So if you head back to your reference page and click on the for statement here, you'll see that the for loops repeat some statement or some activity, right? But the for loops incorporate a counter, and the counter is going to increment and ultimately be responsible for terminating the loop. So in this example here, you'll see that the statement is to printline the value of x. And in my declaration of the for loop here, I initialize a variable here. Okay, this will be an integer value, and this will be x. And we'll set it equal to 0 to begin. Then here's our condition for operation here. So while x is less than 100, we'll perform the statement. And then we will go ahead and increment our counter to the next value, right? So the first time we run through, it'll be 0, and then we'll increment it up to 1. And if I continue this process, printing each value of x throughout the loop, I will have printed the numbers 0 to 99 on my serial stream. So here we've written some code that incorporates a for loop that will increment through all of the addresses of an 8-to-1 multiplexer. So you see here in your loop function, we encounter our for loop. So this says for the integer I, this is a variable I, and we're initializing that equal to 0. So for I equals 0, while I is less than num loops, where num loops is another integer variable I've defined up here as a global variable, and I've gone ahead and initialized that equal to 8. So while I is less than 8, go ahead and increment I by 1, so I++. So while that's happening, we'll serial.print the text mux address equals, and then we'll serial.println I, so that'll go from 0 to 7. And then I've incorporated a delay here of about a second so that we can see this on the screen a little bit more clearly. So we can go ahead and upload to our Arduino, and once that's finished, we can take a look at the serial monitor. And as we see here, we're looping through our loop function. And due to the for loop here, we're printing 8 lines, mux address equals 0, all the way up to mux address equals 7. And you'll notice the 1000 millisecond or the 1 second delay between printing these 8 lines due to the for loop. Let's enhance this code then to control a bunch of output pins depending on what this mux address is. Right, so to do this, I'm going to use a couple if statements. There's certainly more elegant ways of doing this, and you're certainly encouraged to pursue those. But I'm going to go ahead and use a bunch of if statements to tackle this. So the finished code looks just like this, right? In my loop function here, I'm going to loop continuously through, and I'll first encounter a for loop that will increment I from 0 up to 7, looking for each mux address. And then based on the mux address, I'll be looking at a bunch of nested if loops. So in the case I equals 0, I'll digital write pins 2, 3, and 4 low. In the case I equals 1, I'll digital write pins 2 and 3 low and 4 high, right? That's equivalent to 1 times 2 to the 0, which is 1, all the way down to I equals 7, in which case I'll digital write pins 2, 3, and 4 all high, right? And that'll be equivalent to 2 squared plus 2 to the 1 plus 2 to the 0, which is 4 plus 2 plus 1, which is 7. And here I've copied the code over to Tinkercad. I've actually reduced the delays a bit in the interest of time. And we'll go ahead and upload and run the code. And we'll see that the circuit is circling through the addresses 0 through 7 and illuminating the corresponding LEDs to actually describe the address number.